The scene begins with a visual representation of radio static. This static symbolizes the pervasive background noise of space. Gradually, the static diminishes, giving way to a distinct, rising tone. This tone signifies the emergence of an unusual and significant signal. A simulated old computer printout paper is displayed, showcasing raw scientific data. The printout contains a sequence of numbers and letters, representing complex information. This data is typically generated by scientific instruments or computational models. A hand then interacts with the printout, indicating human engagement with the data. The word "wow" is written next to a specific code sequence, highlighting a discovery. This action illustrates the initial human reaction to identifying significant patterns or results within the data. The vast expanse of deep space is characterized by an infinite scattering of stars and galaxies. This cosmic environment serves as the backdrop for understanding the origin of distant signals. A continuous zoom into this star-filled void emphasizes the immense scale of the universe. This visual progression establishes the profound cosmic context from which a signal might emanate. The deep space view highlights the potential for phenomena occurring light years away. A strong radio signal has been detected, originating from space. This signal exhibits highly unusual characteristics, setting it apart from known celestial phenomena. The anomaly demands careful scientific investigation and analysis. Its unique properties suggest a potential deviation from standard astrophysical explanations. Researchers are actively studying the signal's frequency, modulation, and duration. The objective is to determine the origin and nature of this unprecedented cosmic transmission. A visual simulation illustrates the distinct characteristics of a target signal. This signal is presented within an environment containing typical background noise. The simulation highlights the unique properties that differentiate the signal. These properties allow for clear distinction from random or ambient interference. The analysis emphasizes the signal's distinctiveness, crucial for accurate data interpretation. A transient signal is characterized by its brief, non-repeating nature. It was detected as a singular event, occurring only once within the observation period. Crucially, this signal never repeated, distinguishing it from recurring phenomena. This non-repetition establishes the central puzzle of its transient characteristic. The unique, isolated detection presents a significant challenge for scientific analysis. Understanding such fleeting events requires specialized methods and interpretive frameworks. The WOW signal is a significant event in the search for extraterrestrial intelligence, SETI. It was detected on the 15th of August, 1977, by the Big Ear Radio Telescope at Ohio State University. The signal lasted for 72 seconds and originated from the constellation Sagittarius. Its intensity was 30 times greater than the background noise, leading to the observer's "wow" annotation. The signal's characteristics match theoretical expectations for an interstellar transmission. Despite extensive searches, the signal has never been detected again, leaving its origin a mystery. The Big Ear Radio Telescope was instrumental in significant astronomical observations. This instrument was located at the Ohio State University Radio Observatory. It operated as a transit telescope, utilizing Earth's rotation to scan the sky. The Big Ear was renowned for its role in the SETI program, searching for extraterrestrial intelligence. An archival image identifies this specific instrument responsible for a notable detection. On the 15th of August, 1977, a significant astronomical event occurred. The Big Ear Radio Telescope, located in Ohio, detected an unusual signal. This detection marked a specific moment in the search for extraterrestrial intelligence. The event is famously known as the WOW signal due to its intensity. The search for extraterrestrial intelligence, SETI, employs sky surveys to detect potential alien signals. These surveys involve scanning vast regions of space using radio telescopes and other instruments. The goal is to identify anomalous patterns or transmissions that suggest intelligent origin. Any detected signal is then analyzed and placed within the broader context of SETI research. A recreated computer printout is displayed, showcasing a significant historical artifact. This printout represents an early milestone in computing history. The WOW annotation is clearly visible on the document. This annotation highlights a moment of discovery or achievement. The recreation emphasizes the printout's historical and cultural significance. It serves as a tangible link to foundational developments in technology. The WOW signal was a strong narrowband radio signal detected by the Big Ear Radio Telescope in 1977. Astronomer Jerry Eman discovered the anomaly while reviewing data from the Search for Extraterrestrial Intelligence, SETI. He famously circled the signal on a printout and wrote, "Wow," next to it, indicating its unusual intensity. The signal lasted for 72 seconds and matched the expected characteristics of an interstellar transmission. SETI, the Search for Extraterrestrial Intelligence, is a scientific endeavor. Its primary mission is to detect signs of intelligent life beyond Earth. SETI primarily focuses on analyzing electromagnetic radiation, particularly radio signals. These signals are monitored for patterns that cannot be explained by natural phenomena. The goal is to identify artificial transmissions as evidence of alien civilizations. The Big Ear Radio Telescope played a significant role in the Search for Extraterrestrial Intelligence, SETI. During the 1970s, Big Ear was dedicated to observing radio frequencies for potential alien signals. Its primary mission was to detect non-natural radio emissions from deep space. The telescope's observations were crucial for early SETI research efforts. This work contributed to our understanding of the universe and the search for life beyond Earth. The Ohio Memory Digital Archive serves as a vital repository for historical documents and artifacts. It is dedicated to the preservation and accessibility of Ohio's rich cultural heritage. This archive digitizes various materials, making them available to the public online. Among its collections is a famous printout, meticulously preserved for future generations. The archive ensures the longevity and widespread access to significant historical records. The WOW signal was a powerful, narrowband radio signal detected in 1977 by the Big Ear Radio Telescope. A visual graph illustrates its unusual strength compared to typical cosmic radio emissions. Its intensity far exceeded background noise, making it a significant anomaly. The signal's characteristics suggested a non-terrestrial, artificial origin, though never confirmed. A spectrum analyzer graphically displays signal characteristics. It illustrates the distribution of signal power across various frequencies. Narrowband signals are concentrated within a very specific, limited frequency range. This concentration is clearly visible as a distinct peak on the spectrum analyzer display. In SETI research, scientists look for signals that indicate extraterrestrial intelligence. Narrowband radio signals are considered strong candidates for artificial origin. Natural cosmic phenomena typically produce broadband radio emissions. The precise, focused nature of narrowband signals suggests deliberate engineering. The code 6EQUJ5 is displayed, representing a sequence of data points. Each character within the code corresponds to a specific signal. An animated sequence illustrates how each character's signal intensity changes. These changes are visualized over a defined period, showing temporal variations. This visualization method allows for the analysis of signal dynamics and patterns. The Big Ear Telescope utilized Earth's rotation to perform its sky surveys. This rotation allowed the telescope's fixed beam to sweep across different sections of the sky. As Earth turned, the beam effectively scanned a specific area of interest. Each scan of a particular sky region lasted for approximately 72 seconds. This method enabled continuous observation without physically moving the large telescope structure. The Earth's rotation thus served as a crucial component of the Big Ear's observational strategy. A graphic timeline illustrates the precise duration of a signal. This signal is specifically measured to last for 72 seconds. The 72-second duration directly corresponds to the telescope's observation window. This matching ensures optimal data capture during the observation period. The SETI program monitors cosmic radio signals for signs of extraterrestrial intelligence. One significant event involved the detection of a specific signal sequence. This sequence was identified as 6EQUJ5, a unique and strong radio burst. SETI confirmed this signal represented a powerful narrowband event. Such events are of particular interest in the search for intelligent life beyond Earth. The Big Ear Radio Telescope utilized a unique observing method to scan the sky for signals. Its design meant that any celestial object would pass through its field of view for a specific duration. This transit time was precisely calculated based on the Earth's rotation and the telescope's fixed position. Consequently, a detectable signal from a single source would register for exactly 72 seconds. This 72-second duration was a critical characteristic for identifying potential extraterrestrial signals. The Sagittarius constellation is a prominent feature in the night sky, located in the southern celestial hemisphere. It is recognized by its distinctive teapot asterism, a pattern of bright stars. Astronomers use star maps to identify and track celestial objects and phenomena. A star map highlights the specific region of the Sagittarius constellation. This highlighted area indicates the apparent origin point of a detected signal. Pinpointing the source helps in further analysis and understanding of the signal's nature. A graphic visualization depicts a signal's trajectory. The signal is shown originating from a distant point in deep space. This visual representation distinguishes its source from Earth-based interference. The graphic confirms the extraterrestrial origin of the detected signal. It highlights the signal's journey across vast cosmic distances. The Big Ear Telescope, a radio observatory, had a unique design for astronomical research. Its primary function was to detect radio signals from celestial sources across the cosmos. However, the telescope's design presented inherent limitations in source localization. It struggled to precisely pinpoint the exact origin of detected signals. This characteristic made it challenging to narrow down specific celestial coordinates. Scientific investigations often encounter limitations in precisely pinpointing the origin of phenomena. A key factor contributing to this uncertainty is the design constraints inherent in observational instruments. For instance, telescopes, while powerful, have specific design parameters that affect their accuracy. These constraints can limit the resolution or field of view, making exact source localization challenging. Consequently, scientific data may indicate a general area rather than a precise point of origin. The signal's origin was confirmed through analysis of astronomical data. Britannica reference materials corroborate the findings. The signal appears to originate from the constellation Sagittarius. This celestial region is known for its dense star fields and galactic center. Further investigation is required to pinpoint the exact source within Sagittarius. The SETI Institute plays a crucial role in the search for extraterrestrial intelligence. They analyze vast amounts of data from radio telescopes to detect potential signals. Recent findings include a signal whose apparent source is the Sagittarius constellation. The Institute's analysis reinforces Sagittarius as the confirmed direction of origin. This confirmation is a significant step in identifying the signal's celestial coordinates. The WOW signal remains one of the most intriguing mysteries in the search for extraterrestrial intelligence. It was detected on the 15th of August, 1977, by the Big Ear Radio Telescope at Ohio State University. The signal was a strong, narrow-band radio emission, lasting for 72 seconds. Its characteristics closely match theoretical expectations for an interstellar signal of artificial origin. Astronomer Jerry Eamon circled the anomaly on a printout and wrote, "Wow," beside it. Despite numerous attempts, the signal has never been detected again, leaving its origin unknown. A visual meter indicates the current level of scientific excitement regarding a particular signal. The meter's reading reflects the perceived potential significance of the detected signal. A peak on the meter signifies a high degree of interest and anticipation within the scientific community. This visual representation quantifies the scientific community's response to new discoveries or data. The analyzed signal exhibits distinct and unique characteristics. A primary feature is its strong intensity, indicating significant power. The signal is also narrowband, confined to a specific frequency range. These attributes differentiate it from ordinary, broad, natural radio noise. SETI researchers are particularly interested in signals exhibiting specific characteristics. These features often include narrow bandwidth, indicating an artificial origin rather than natural phenomena. Repetitive patterns or sequences within the signal can also suggest intelligent design. Such distinct attributes make a signal a compelling candidate for further investigation by SETI. The WOW signal is a unique radio signal detected in 1977 by the Big Ear Radio Telescope. Its distinct characteristics set it apart from typical natural radio emissions. Natural radio noise often presents as chaotic and broad spectrum, lacking specific patterns. In contrast, the WOW signal displayed a narrowband, ordered pattern concentrated at a specific frequency. This ordered structure suggests a potential artificial origin, unlike the random nature of cosmic background noise. The WOW signal is one of the most famous potential SETI candidate signals ever recorded. It was detected on the 15th of August, 1977, by Dr. Jerry R. Eamon using the Big Ear Radio Telescope. The signal lasted for 72 seconds and originated from the constellation Sagittarius. its intensity was 30 times greater than the background noise, leading to Eamon's famous annotation, "Wow." The WOW signal is a famous candidate for an extraterrestrial radio transmission. It was detected on the 15th of August, 1977, by the Big Ear Radio Telescope at Ohio State University. The signal lasted for 72 seconds and originated from the constellation Sagittarius. Its intensity was 30 times greater than the background noise, a significant anomaly. Astronomer Jerry Eamon circled the anomaly on a printout and wrote "WOW" beside it. Despite extensive searches, the signal has never been detected again, adding to its mystery. SETI, Search for Extraterrestrial Intelligence, monitors cosmic signals for signs of intelligent life. Occasionally, SETI detects signals that defy conventional astrophysical explanations. One such signal has been characterized as among the most compelling in SETI's history. Its unexplained nature makes it a significant focus of ongoing scientific investigation. The system initiated a sequence of attempts to re-establish signal detection. Each subsequent attempt to detect the signal proved unsuccessful. A visual timeline illustrates the progression of these repeated failures. Despite multiple efforts, the signal remained undetectable by the system. This indicates a persistent issue preventing successful signal acquisition. The scientific community maintains a cautious stance regarding observed phenomena. This caution is primarily driven by the non-repetition of the signal or event. Reproducibility is a fundamental principle in scientific validation. Without consistent replication, findings are considered preliminary and require further investigation. The search for extraterrestrial intelligence, SETI, involves detecting signals from other civilizations. A fundamental scientific principle in SETI is the importance of repeatability for validation. Repeatability means that an observation or experiment can be replicated with consistent results. In SETI, a detected signal must be repeatable to be considered a genuine extraterrestrial communication. A single, unrepeatable detection could be attributed to interference, equipment malfunction, or random noise. Therefore, repeatability is crucial for distinguishing true signals from false positives in the search for ET life. A single, unrepeated signal presents significant challenges for verification. Without repetition, establishing the signal's origin becomes extremely difficult. The nature or intent behind such a singular event is hard to ascertain. Lack of corroborating data impedes any attempt at robust analysis. Proof requires multiple observations or a consistent pattern of occurrence. Therefore, a unique signal often remains unprovable in its authenticity or source. The search for extraterrestrial intelligence often involves detecting unique signals from space. A crucial criterion for validating such signals is their repeatability and consistent detection. If a signal is detected only once and never found again, its origin remains unconfirmed. Therefore, a non-recurring signal is not considered a strong candidate for extraterrestrial intelligence. Theory A proposes that a recently detected signal originates from an extraterrestrial source. This theory suggests the signal is not a natural phenomenon or human-made interference. Instead, it is posited as a deliberate transmission from an intelligent civilization beyond Earth. The signal's characteristics are analyzed for patterns indicative of artificial origin. Scientists examine frequency, modulation, and duration for non-random sequences. Confirmation of this theory would represent a monumental discovery in astrobiology. A theoretical framework often provides the foundational understanding for complex phenomena. When a theory successfully explains a signal, it elevates its significance and public interest. This theoretical validation transforms a mere observation into a recognized scientific discovery. The theory's explanatory power contributes directly to the signal's fame and widespread recognition. The search for extraterrestrial intelligence, SETI, often focuses on detecting specific signal types. One such type is a narrowband signal, characterized by its concentrated frequency. This narrowband characteristic is significant because natural cosmic phenomena typically produce broadband emissions. Therefore, a narrowband signal is considered a potential indicator of artificial origin. SETI researchers specifically hope to find such signals, as they suggest intelligent communication. Understanding the distinction between possibility and evidence is crucial in scientific and logical reasoning. A possibility refers to something that could potentially happen or exist. It is based on theoretical considerations or a single, unverified observation. However, a possibility alone does not constitute evidence of its reality. For something to be considered evidence, it requires repeated detection or verifiable corroboration. Without consistent, verifiable data, a concept remains merely a possibility, not a proven fact. This segment introduces Theory B, human-made interference as a potential explanation. This theory explores the impact of human activities on a given phenomenon. It posits that deliberate or accidental human actions are a primary cause. Such interference can manifest in various forms, from technological to environmental. The analysis will delve into specific examples and mechanisms of human influence. This theory stands as a distinct alternative to other potential explanations. A terrestrial source refers to any signal originating from Earth-based infrastructure. These sources are typically fixed installations, such as ground transmitters or broadcast antennas. They are designed to emit signals over a specific geographic area. The signals can be used for communication, navigation, or data transmission. Unlike satellite-based signals, terrestrial signals are subject to Earth's curvature and terrain. This can impact signal range and reception quality, requiring strategic placement of transmitters. Interference refers to unwanted signals that disrupt astronomical observations. These signals can originate from various sources, both terrestrial and extraterrestrial. A significant challenge arises when interference is reflected back towards telescopes. This reflection can occur off space debris orbiting Earth. Atmospheric layers, such as the ionosphere, can also act as reflective surfaces. Reflected interference degrades data quality, hindering accurate scientific analysis. Terrestrial interference can cause a signal to appear once and then not again. This phenomenon occurs when radio waves from ground-based sources disrupt satellite signals. The interference is often transient, caused by moving objects or atmospheric conditions. A momentary alignment of the interfering source and receiver can create a single detection. As conditions change, the interference dissipates, preventing subsequent signal reception. The WOW signal was a strong narrowband radio signal detected in 1977 by Jerry Eman. Despite its unusual characteristics, Eman himself harbored skepticism about its extraterrestrial origin. He considered the possibility that the signal could have been terrestrial interference. This highlights the scientific rigor applied to anomalous observations, even by their discoverers. The Ohio State recap initially presented certain findings or events. However, subsequent analysis led to growing skepticism regarding these initial conclusions. One significant area of doubt involved the potential for terrestrial interference. This interference suggests that external, Earth-based factors may have influenced the data. Such possibilities necessitate a re-evaluation of the original recap's accuracy and validity. Theory C proposes an alternative explanation for the observed phenomenon. This theory posits that the event is a natural astronomical occurrence. It suggests the phenomenon aligns with known celestial mechanics. Theory C offers a scientific framework for understanding the event. Hydrogen, the most abundant element, forms vast clouds in interstellar space. These cosmic hydrogen clouds are fundamental to the universe's structure and evolution. They consist primarily of atomic and molecular hydrogen, along with dust and other gases. Gravitational forces within these clouds can lead to the collapse of denser regions. This collapse initiates the formation of new stars and planetary systems. Thus, hydrogen clouds serve as natural nurseries for stellar birth and cosmic evolution. Natural phenomena can theoretically produce specific signals. One such example involves effects related to hydrogen clouds. These clouds, under certain conditions, can generate detectable emissions. Understanding these natural processes is crucial for signal interpretation. Scientific inquiry continuously evolves, leading to new perspectives on established phenomena. Historically, certain events were attributed to supernatural or unexplainable forces. However, advancements in various scientific fields have facilitated deeper understanding. Recent studies have increasingly focused on identifying natural explanations for these occurrences. These investigations employ rigorous methodologies to uncover underlying physical or biological causes. This shift emphasizes empirical evidence and rational analysis in scientific discourse. Scientific proposals undergo rigorous evaluation within the research community. Initial proposals often present novel ideas or interpretations. Some proposals are deemed interesting, sparking further discussion and investigation. However, interesting does not equate to universal acceptance. Universal acceptance requires robust evidence and peer consensus. Proposals lacking widespread scientific support remain under scrutiny. The SETI Institute's hypothetical 2025 report proposes a novel, natural explanation for certain phenomena. This report challenges previous assumptions by suggesting non-artificial origins for observed data. It introduces a new framework for interpreting astronomical and observational anomalies. The explanation focuses on previously overlooked astrophysical processes or cosmic events. This groundbreaking research aims to refine our understanding of the universe's natural mechanisms. The WOW signal remains one of the most intriguing, unexplained phenomena in radio astronomy. Despite new proposals and extensive research, its origin has not been definitively identified. The signal's unique characteristics suggest a potential extraterrestrial source. However, no subsequent detection or conclusive evidence has emerged to confirm this. Therefore, the case for the WOW signal is still considered open, awaiting further scientific breakthroughs. The WOW signal represents a unique and perplexing event in scientific exploration. It occupies a frustrating middle ground in our understanding of extraterrestrial intelligence. The signal was strong and narrow band, consistent with an artificial origin. However, its non-repetition prevents definitive confirmation or dismissal of its nature. Some phenomena are significant enough to warrant attention and investigation. However, their fleeting or isolated nature makes them difficult to observe consistently. This brevity and isolation prevent comprehensive data collection and empirical verification. Such events present a paradox. They are important but lack verifiable evidence. The scientific importance of certain findings often transcends initial assumptions. Its value does not lie in proving the existence of extraterrestrial life. Instead, its true significance is in highlighting the difficulties of signal verification. This demonstrates the complex challenges inherent in authenticating novel scientific data. In many fields, identifying crucial information amidst overwhelming data is a significant challenge. This challenge involves distinguishing extraordinary signals from background noise or interference. Extraordinary signals represent rare, significant events or data points. Noise refers to random fluctuations or irrelevant data that obscure these signals. The difficulty lies in developing methods to accurately isolate these vital signals for analysis. Inference-based conclusions are drawn from indirect evidence or reasoning, rather than direct observation. Such conclusions often arise when data is limited or ambiguous, requiring interpretation. The one-time nature of a signal can lead to an inference-based conclusion due to lack of repetition. A single occurrence makes it challenging to establish causality or rule out anomalies. Ongoing scientific debate also indicates that conclusions are often inferential. Debate signifies that multiple interpretations of available evidence are still under consideration. Scientific consensus represents a collective agreement among researchers on a particular topic. It is typically formed after extensive research, data analysis, and peer review processes. However, some areas of study continue to lack a definitive scientific consensus. This can persist even after decades of follow-up observations and dedicated studies. Such situations indicate ongoing debates, conflicting evidence, or insufficient data. The absence of consensus highlights the complexity and evolving nature of scientific inquiry. Public fascination with certain topics is often driven by a combination of key factors. The element of science provides a foundation of credibility and intellectual engagement. The presence of mystery sparks curiosity and encourages deeper exploration. Utilizing real telescope and real data lends authenticity and verifiable evidence. Observing real scientist reaction adds a human element and emphasizes discovery. The absence of a no final answer sustains interest and invites ongoing inquiry. Science represents systematic inquiry and the pursuit of knowledge through observation and experimentation. Mystery embodies the unknown, the unexplained, and the phenomena that defy current understanding. The blend of science and mystery signifies the frontier where established knowledge meets uncharted territory. This dynamic interaction drives scientific advancement, pushing boundaries to unravel the universe's secrets. The foundation of scientific inquiry begins with direct observation. This process involves systematically gathering data through sensory experience or instrumentation. Unlike anecdotal accounts, scientific observations are verifiable and replicable. They serve as empirical evidence, distinguishing scientific understanding from speculation. This rigorous approach ensures that discoveries are rooted in factual, observable phenomena. The WOW signal stands apart from typical UFO stories due to its scientific basis. Unlike anecdotal accounts, the signal was detected by a radio telescope. Its characteristics, like frequency and duration, were precisely recorded. This objective data lends the "wow" signal significantly greater credibility for scientific inquiry. A signal can possess a haunting quality when it is scientifically legitimate yet remains unresolved. This quality stems from its verifiable existence combined with an unknown origin or explanation. Such signals often challenge established paradigms, prompting deeper scientific inquiry. Their persistence without a clear cause creates a sense of mystery and intrigue within the scientific community. The haunting aspect reflects the tension between empirical evidence and the absence of a complete understanding. The search for extraterrestrial intelligence, SETI, is a scientific endeavor. Its primary goal is to detect and analyze signals from intelligent life beyond Earth. SETI protocols involve rigorous data analysis to identify unusual patterns. A recent event has been formally recognized by SETI as a legitimate scientific anomaly. This classification indicates the event warrants further investigation and study. The signal continues to capture widespread public interest and imagination. Its unique status contributes significantly to its sustained appeal. This phenomenon is driven by various factors, including mystery and speculation. The signal's origins and implications remain subjects of intense public discussion. It serves as a focal point for scientific curiosity and popular culture narratives. The graphic illustrates the continuous engagement of the public with this distinct signal. The WOW signal was a powerful, narrowband radio signal detected in 1977 by the Big Ear radio telescope. It lasted for 72 seconds and originated from the direction of the constellation Sagittarius. The signal's characteristics were consistent with an extraterrestrial origin, making it highly unusual. Despite numerous attempts, the signal has never been detected again, adding to its enigmatic nature. To this day, no universally accepted explanation for the WOW signal has been found. The concept of alien origin often sparks widespread public interest and speculation. However, scientific methodology demands rigorous evidence for any extraordinary claim. A crucial aspect of scientific inquiry is maintaining neutrality until confirmation. Therefore, any claim of alien origin remains unconfirmed without verifiable data. This approach ensures that conclusions are based on facts, not assumptions or beliefs. The WOW signal represents a pivotal moment in the search for extraterrestrial intelligence. It was a powerful, narrowband radio signal detected by the Big Ear radio telescope in 1977. The signal lasted for 72 seconds, exhibiting characteristics consistent with an artificial origin. Its intensity and frequency made it stand out dramatically from background noise. Despite extensive subsequent searches, the signal has never been detected again. This brief, extraordinary event continues to fuel humanity's wonder about life beyond Earth.